Okay, a new paper just came out in Nature Communications by Kerry Emanuel of MIT, who's, of course, spent a lifetime working on hurricanes, cyclones, and is the king of cyclones. The main point he tries to make in this paper, or he makes in this paper, is that the hurricane activity has intensified over 150 years, so we will see how they reconstructed that, and then that the local climate change or warming over the North Atlantic is what is responsible for that, which is not to take away from the fact that global warming is going to cause or is already causing intensification and other things. So this is from his other paper, also from 2021 in Journal of Climate, where he looks at annual global frequency of downscaled tropical cyclones. Solid curves represent multi-model means, and shading indicates one standard deviation up and down. Dashed lines show linear regression trends. If you don't see it, don't worry about it. Blue indicates historical period here, 1850 to 2014, while red is the 1% per year CO2 increase experiment arbitrarily beginning in 1970. Green curves show the multimodal mean and globally summed Genesis potential index. That's a lot of information, but essentially because the global models do not resolve cyclones, hurricanes explicitly, he uses this downscaling model where he provides the boundary conditions from the global models in terms of, let's say, warming in response to 1% CO2 increase per year. 1% CO2 increase per year gives about doubling in 70 years, which is where we are headed almost. Not quite, but almost. So historically, there's been debates about globally what happens to the cyclone activity. So the advantage here of downscaling is that using multiple reanalysis products, he can go back to 1850, whereas if you just try to rely on data, then the data becomes quite sparse very quickly beyond about 1950 or so. So this gives you a long-term perspective, which is useful. Again, global frequency, and there is you can see the blue line here making a turn, which we said this is annual frequency, so we're looking at 20th century 1% CO2 increase, and the green line is the GPI. So GPI is the Genesis potential index. If you remember already, it depends on ocean conditions, vorticity, vertical shear, moisture loading, vertical velocity in the atmosphere, and so on. So the historical period has already been showing annual frequency of tropical increase in the annual frequency of tropical cyclones at least since about the 1970s and maybe before. And this is just to confirm that future with warming and increasing CO2 is going to bring increasing global cyclone activity, and Genesis potential is going to increase as well, which includes ocean warming, atmospheric circulation changes, and so on. So the new paper basically looks at this again in terms of historical and future periods using historical period going from again 1840s to 2020 or so. Time series of North Atlantic landfall events, basin hurricanes, and major hurricanes. So now we are zooming into the North Atlantic. The landfall frequency includes only storms whose lifetime maximum wind speeds exceed 40 knots. Middle row shows basin frequencies, and bottom row shows basin-wide major hurricane frequency. So if you don't have data in the middle of the ocean, as you go back in time, ships would report hurricane storms, cyclones, but most of the records can be biased by landfall because those are the ones that get documented very well in terms of wind speeds categories before categories became formalized and so on. So downscaling, on the other hand, gives you a good comparison of landfall hurricanes and basin scale hurricanes, and these are the three reanalysis products being used here. Red curve shows quantities associated with tropical cyclones downscaled from 3 global climate reanalysis here, and blue curves derived from uncorrected historical tropical cyclone data. So you can see that the differences can be substantial when you just rely on data versus when you do the synthetic tracks with downscaling. So some of them have bigger differences than the others. So these are, this is a shorter period of course, but these are much more in agreement than this one here for all three categories. So landfalls, basin scale, and major hurricanes. Okay, let's leave it there, basically taking home the point which I will make again at the end, that there is an increase in cyclone activity over this longer than almost 150 years, actually more than 150 years. Here again looking at similar to figure 1 but showing continental US annual landfall frequency and US landfall power dissipation index, which is a measure of how strong the cyclone was. The landfall frequency includes only storms whose lifetime maximum speeds, wind speeds exceed 40 knots. Land power dissipation is in units of meter cube per second cube, so it relates to wind speeds. Linear regression lines in the bottom row are from ordinary linear regression. So even for the US or for all of the North Atlantic, you get a similar conclusion. And if you look at global annual number of tropical cyclones and major hurricanes from IB tracks, historical data and downscaled from reanalysis, global tropical cyclone count shown at left here and major hurricanes on the right here. Reanalysis used are indicated here in legends. Downscaling from a second ensemble member of SARA 20C is also shown here by the magenta curves, and the historical data are shown by the thicker black curves. Dashed curves show Poisson regression for each reanalysis as opposed to the linear regression we used before. Okay, so you can see that when we look at the number of tropical cyclones for the global region, the trend is not necessarily upward, but this differs significantly between the reanalysis product that's used as boundary condition for forcing the regional downscaling. But the number of major hurricanes show an increase in all three of them. Okay. The main point I want to make here is again looking at perturbation potential intensity from 1900 to the recent decade. So in the black curve is the perturbation potential intensity, global contribution and regional contribution, and number of tropical cyclones. Okay, so this shows that when you look at 7-year running means of Atlantic main development region over this box, August to October departures of potential intensity, maximum intensity you could get associated with the warming. We've talked about this before. From its mean over the record and its decomposition into global and regional components. The 7-year running mean of the annual frequency of tropical cyclones downscaled from SARA 20C is shown in blue in the frequencies here. So the main conclusion drawn from this paper is that most of the variability of North Atlantic tropical cyclone activity over the last century was directly related to regional rather than global climate change. When we look at trend maps of warming, for example, there are obviously regional contrasts in the warming. Indian Ocean is warming much faster, West Pacific is warming, North Atlantic is warming, but it's mostly dominated by polar amplification way north. Tropical Atlantic, where most of the cyclogenesis happens, is not warming as fast as the Indian or West Pacific Ocean. Most metrics of tropical cyclones downscaled over all the tropics show weak and or insignificant trends over the last century, illustrating the special nature of the North Atlantic tropical cyclone climatology. This should give us a pause in the sense when we begin to compare trends in the Bay of Bengal or Arabian Sea with the tropical cyclones or hurricanes over the North Atlantic or typhoons over the northwest tropical Pacific. We have to be careful because local climate change rather than global climate change may be more important for genesis GPI, Genesis Potential Index, and other actual number of cyclones and power dissipation index and so on. So there are 4 features of downscaled Atlantic tropical cyclone climatology shown in figure 1 that stand out. A substantial upward trend in most metrics, so that's for the Atlantic. Local maximum in most metrics in the 1930s and early 40s. A profound depression of activities in the 1970s and 1880s, and a pronounced uptick in activity after 1990. So going back to figure 1 here, he's talking about the regional flattening and pickup and the trend, overall trend. So when we draw long-term trends, they can be different than when you look at secular trends or multi-decadal variability in them in detail. Those matter as well, because over the North Atlantic the warming is and the dust loading are responsible for cyclone activity as well in terms of the strength and number, etc. And the warming related to Atlantic multi-decadal oscillation, which was considered an internal mode, is now questioned as to whether it's just a statistical artifact and whether the dust loading is related to aerosols, industrial aerosols, or rainfall deficit caused over North Africa related to the industrial aerosol forcing over the North Atlantic. So indirect dust loading forced by industrial aerosols coming from the Sahara-Sahel region. So things get complicated, but the main take-home message I would want to leave you with is that hurricane activity has been increasing over the North Atlantic, but it is mostly related to local climate, local warming, not global warming. And remembering that the global cyclone numbers are part of the overall energy transport from the equator towards the poles required by the energy surplus and energy deficit, how the regions of cyclogenesis over the Atlantic, Pacific and Indian Ocean in the northern hemisphere, and of course there are also similar regions in the southern hemisphere, even though South Atlantic shows almost no cyclone activity. Then you have to be very careful about what is being controlled by local climate and what is related to the global climate and the global equator to pole temperature gradient. So these sorts of details could benefit from doing a similar analysis of downscaled cyclone activity over the Indian Ocean, for example. Okay.